L'Hopital's rule can be used to very quickly and easily prove the small angle theorem. And the small angle theorem says this: sine x over x is equal to 1 for small values of x. And that's an important little theorem. And you can see this graphically. Take a look. The graph, it's really easy to see this theorem if you graph the functions. So sine x looks like this. Okay, so that's a graph of y equals sine x. And then y equals x looks like this. So again, I'm thinking of the numerator and denominator as two separate functions, and there we have a graph of each one. And those graphs line up really closely right through there, right through the origin. If we're close to an x value of 0, that's what we mean by small x, then those two graphs are essentially the same. So sine x over x, if they're essentially the same, one thing over another, if they're both the same, then it evaluates to 1. And then, of course, we can express this fact with limit notation. We would say the limit as x approaches 0 of sine x over x is equal to 1. And that's actually a very important little result. There are some important concepts in physics and engineering that depend on that result when you're working through the details and the analysis. So let's prove this with L'Hopital's rule. This is quick and easy. We'll start off with this: the limit as x approaches 0 of sine x over x. And you can see that if we let x equal 0, we get 0 over 0. That's an indeterminate form. So let's apply L'Hopital's rule, and we get the limit as x approaches 0 of the derivative of the numerator, which will be cosine x, over the derivative of the denominator, which will be 1. And this can be evaluated with a substitution. Put in 0 for x, and cosine of 0 is 1. And we just have 1 over 1, which is 1. And that's it. The small angle theorem has been demonstrated or proven with L'Hopital's rule.